Our operations audit at the Ecos vegetable straw factory in Hanoi showed we're losing too much efficiency. Right now, overall equipment effectiveness is stuck at 58%, mostly because 8.5% of our daily 200,000 straws end up deformed, uneven, or cracked after drying. The main culprits? A lack of automated temperature and moisture sensors in the drying chambers, plus worn-out molding tools at the extrusion stage. To fix this, we're planning a quick turnaround, installing inline digital sensors, realigning the mechanical rollers, and standardizing our mixing formulas. The best part is the numbers. It only requires a 115 million VND upfront investment, but it will save us 1.224 billion VND annually. That's a massive 964.35% return on investment with a payback period of just 1.13 months. It's a highly viable project, and we should definitely move forward with it immediately. To get this done smoothly, we've structured a 24-week plan, split into 3 waves. First, from weeks 1 to 6, we'll handle the basics like standardizing processes and calibrating the molds. Then, between weeks 7 and 14, we'll bring in the tech to install and calibrate the digital sensors in the drying chambers. Finally, from weeks 15 to 24, we'll lock everything in with quality control loops, team training, and final audits. To pick the best factory for our project, we used a decision matrix, and the Ecos Straw Factory came out on top with 424 points, way ahead of Diana Unicharm and Hunufa. The biggest factor was its proximity to NEU, which scored a 9 out of 10 and saves us tons of travel time. Plus, Ecos scored highest in critical areas like permission likelihood, safety, management cooperation, and data transparency, making it the easiest and most practical choice for our research. The Ecos Straw Factory in Hanoi, run by the Song Hong Cooperative since 2019, makes 100% biodegradable, edible straws from grain and vegetables. It's a great case study because handling organic materials requires super strict temperature and moisture controls. Their straws come in sizes from 4.5 millimeters to 13 millimeters, last up to 10 hours in drinks, and serve a huge B2B market, from local high-end resorts to global buyers in the US, Europe, and Asia. Backed by a $2.8 billion global green market and aiming for a 5-star OCOP rating, the factory runs a centralized collaborative setup. Their local and technical team handles everything from raw farming to advanced extrusion, pushing out 200,000 straws daily and scaling up to 1.3 million for export containers. The Ecos factory's 8.5% defect rate is costing them a massive 446,760,000 yuan Nam dollars annually. Using an Ishikawa fishbone analysis, the team traced the root causes to 2 main issues: straw deformation from worn molds, roller pressure variations, and misalignments, and brittle cracking due to unstable drying temperatures and lack of moisture testing. Applying the Pareto principle, management shouldn't try to fix everything at once. Instead, they need to focus resources entirely on these 2 high-impact areas: post-drying cracking and extrusion deformation, to eliminate the vast majority of their scrap and rework costs. Our Pareto analysis shows that post-drying cracking and straw deformation cause nearly 78.2% of all quality losses, so that's exactly where we need to focus. Post-drying cracking alone is the biggest financial drain, costing us 625 million VND annually. The root issue is that operators are running the ovens on fixed timers instead of real-time data because they don't have digital moisture testing tools. When the factory's ambient humidity drops or the initial mix is too dry, the straws over-dry and crack down the middle. Once that happens, the material is completely unrecoverable, meaning we lose both the raw materials and the energy used. Straw deformation and uneven sizing cost the factory 446,760,000 VND annually. Molds worn out and uneven roller pressure create uneven straw walls that warp during cooling. Combined with the 625 million VND drying phase loss, these failures crush production capacity and profitability. We mapped the entire process from receipt to packaging to spot hidden inefficiencies. The current chart reveals major logical flaws at inspection node Q4. If raw flour passes the moisture check, it entirely skips washing, peeling, grinding, and cooling to jump straight to extrusion. If it fails, it bypasses crucial cooking and pelletization. This messy setup proves a severe lack of standardized procedures, driving up process variability. To pinpoint the exact bottlenecks, the table below breaks down the resources, cycle times, and equipment metrics for each step. Cycle time analysis proves that the 8-hour tray drying stage is the primary system bottleneck, while upstream steps take only 30 to 60 minutes. Per the theory of constraints, this single mismatch chokes overall throughput, causing massive work-in-process inventory, labor idle time, and severe waiting waste. Because upstream stages produce faster than the ovens can process, reducing drying cycle time must be the factory's highest priority to restore workflow balance. The 50-meter manual transit of fragile, undried straws to the oven causes severe bending and splitting, costing 474 million BND annually in transportation waste and delays. This flawed physical layout increases handling frequency and product damage while exposing severe labor underutilization, with workers spending 20% of their shifts waiting due to upstream blockages. Furthermore, lacking real-time tracking, maintenance remains reactive, triggering a 14% unplanned downtime on extrusion and cutting rigs. Ultimately, this combination of excessive transport and reactive maintenance spikes process variability and drains factory productivity. The field photograph captures our team and supervisors evaluating the main processing room, which lacks floor markings to separate pedestrian paths from material staging areas, risking contamination, material damage, and accidents. Our formal safety assessment identified uninsulated steam systems and tray ovens as the highest operational risks due to severe thermal burn hazards. Meanwhile, airborne starch dust poses a moderate long-term health risk, and manual lifting of drying trays creates significant ergonomic strain. To align with ISO safety standards, engineering controls must urgently prioritize high-temperature shielding, workplace ergonomics, and improved housekeeping. The steam cooker and batch ovens pose severe burn hazards due to uninsulated pipes and inadequate PPE. Handling 80 degrees Celsius metal trays with basic cotton gloves offers insufficient protection, risking operator burns and dropped trays that cause immediate material scrap and operational delays. Airborne starch dust lacks exhaust ventilation, shorting out electronics and wearing down machinery to cost 75 million VND annually in emergency repairs. Worker absenteeism and insurance penalties drain another 80 million VND, bringing the total hidden penalty to 155 million VND annually. Investing in localized dust extraction is a high-return initiative that completely recovers these losses while boosting plant reliability. To fix these vulnerabilities, the redesigned SOP replaces the illogical workflow with a continuous, unidirectional lean flow. This ensures all raw materials undergo standardized processing through rigorous control thresholds, eliminating skipped preparation stages and premature drying. The redesigned SOP establishes a strict unidirectional sequence that permanently eliminates skipped preparatory steps. By integrating inline infrared moisture sensors and automated drying profiles, the factory resolves straw deformation and brittle fracturing. Safety is upgraded via automated hot tray handling, steam exhaust hoods, and cutter guardrails, while real-time laser calibration and immediate trimming reclamation reduce material scrap to near zero. Ultimately, this architecture shifts operations from reactive sorting to proactive variance prevention, optimizing tray geometry to compress drying cycle times and maximize overall plant capacity. The operational transformations derived from transitioning to the proposed standard operating procedure are quantified in the comprehensive comparison matrix below. The proposed SOP shifts the factory from a volatile to a predictable state, cutting batch cycle times from 360 to 240 minutes and lowering daily labor hours via automated transport. Financially, dropping the defect rate from 8.5% to 1.8% saves 1.224 billion VND annually, while eliminating 6 out of 7 primary safety hazard zones, ensures a stable workplace that boosts daily capacity to 260,000 units. Ultimately, labor productivity nearly doubles to cut marginal costs, driving customer satisfaction to 98.5% and securing a foundation for long-term commercial scale. To safely boost daily production from 200,000 to 260,000 straws, the factory is switching to a real-time KPI dashboard. This system monitors new technical upgrades in real time to prevent quality drops and control variances during extrusion, sizing, and heating. The legacy workflow drains finances through an 8.5% defect rate, costing 1,530 million New Zealand dollars annually, and 42 hours of monthly downtime. To rectify this, a targeted 115 million VND capex investment in automated controls will stabilize operations, dropping defects to 1.8% to generate 1,224 million VND in annual savings. With an exceptional 964.35% ROI, this optimization fully recovers all initial costs within just 1.13 months, converting structural manufacturing waste directly into net margin. The diagnostic investigation of the ECOS facility uses operations management tools to drive strategic improvements. A legacy flowchart and Ishikawa diagram trace the plant's 8.5% defect rate directly to an illogical layout, material instability, and volatile drying profiles, while a safety analysis flagged severe thermal hazards. To resolve this, the proposed SOP enforces a strict unidirectional material flow and automated inline testing nodes rolled out via a phased 3-wave Gantt chart. Backed by a 115 million VND capex, this overhaul recovers 1,224 million VND annually, yielding a 964.35% ROI and a 1.13-month payback period, while permanently compressing defects to 1.8% and neutralizing workplace hazards. And that's the end of our video. Thanks for watching.